Hi, this is Miss Litton, and this is a rainy Wednesday afternoon, and this is an Honors Bio Review. Say hey. Hey. Okay, and we are reviewing the endocrine system. Now, first thing we need to remember is to get a pointer, because I can't reach over there. Okay, purpose of the endocrine system is coordinate the body. What other system helps coordinate the body? Nervous system. Good. So the nervous system and the endocrine system both do that. Now, the difference between an endocrine gland and an exocrine gland, remember, an endocrine gland will put that chemical, that hormone, into a capillary that's passing through that gland. That's how it gets into your bloodstream, and then your blood carries it everywhere else. Whereas an exocrine gland, it's trying to secrete something into like a duct or a tube, like your digestive tube or your salivary glands are trying to put it into your mouth, or a sweat gland. That's an exocrine gland. Endocrine gland goes into the blood. How do hormones work? Hormones work because they're going everywhere. Just like if I wanted to pick up my phone and I could hit it to call everyone, but maybe it just goes to one person, and maybe just Maddie has, I've dialed her phone, so it goes everywhere, but she's the only one who has a what for it? Receptor for that message, so it only affects Maddie. Okay, though the message is blanketing the room. Now, there are varieties on this. Using chemicals as a message, remember at the very end I talked to you about pheromones. Pheromones are a chemical message between two different organisms, right? Hormones are a chemical message between two different parts in your body. Okay, so that's what we're seeing right here. Neurons, when you have, this is a chemical message that goes a teeny tiny distance just across a synapse. This one right here is talking a little bit, neurosecretory cells, you're talking about the hypothalamus and the pituitary gland, because the hypothalamus has those neurosecretory cells. Sometimes they reach all the way in, like to the post pit, because it dropped down out of the hypothalamus. Remember that? In the ant pit, it only gets as far as the stalk. Okay, so that's a neurosecretory cell, kind of an overlap of the nervous and the endocrine system. Okay, who is faster, the nervous or the endocrine system? Nervous, way faster. Who uses neurotransmitters? Nervous system. Who has longer lasting effects? Endocrine system. What is the message of the endocrine system? What do we use? Starts with an H. You're going to be so ready for class. I'm so proud of you. Okay, now, here. Today we were what we were yesterday. You can go in as something you would want to get if you went to Starbucks right now. I can never get cake pops there because one time I got a raw one, so now they're dead to me. Cake pops are dead to me. I bit into it, it was like not cooked.
How did they last that time?
I don't know. It's wrecked me for life. Okay, and I'm going to go ahead and pause this for just a moment because you can't see the questions right now anyway. Okay, we are back. Let's see how you did. Endocrine glands are ductless. Exocrine glands have ducts. Okay? Endocrine glands are ductless because endocrine glands secrete right into your blood, the capillaries.
We're talking about the next one.
Oh, okay. Oh, yeah. Fastest response time is nervous. This is a wrong. Sorry. This should be the right answer.
That was not it.
Yeah.
Everyone gets it.
Okay. Sorry about that. Yes, the fastest response time is nervous. Remind me to fix that in the end when we stop. Okay, if you're here. Okay. Uses primarily a hormone to transfer information. Yes, the endocrine gland does that. Caca. Sorry. I apologize. Whatever. Savannah, Okay. Uses a neurotransmitter to transfer information is nervous system. Good job. And number 5, used to maintain homeostasis, both the nervous and the endocrine system. Who's just faster at it? Nervous. Good job. Okay. Now we move. Okay, we talked about positive and negative feedback. Okay, I am going to draw something and you decide what kind of feedback this is. Okay, 2 graphs here. Drawn really crooked. Okay, what do you think the first graph is here on the left? Positive feedback. It's just going up and up and up and up. Negative feedback, I'm trying to stabilize it, keep that level exactly right. For instance, glucose levels. You don't want to like eat a little bit of sugar and then you get that sugar in your blood and more sugar in your blood and then more sugar in your blood and more sugar in your blood where it starts to put you up into a diabetic shock, right? You want to keep it just right. So insulin lowers the blood sugar level and glucagon raises the blood sugar level, and those are antagonistic hormones that help you maintain your sugar levels just right, and that would be an example of negative feedback. If you're giving birth, you're going to want to keep cranking out those contractions and cranking out those contractions, and you want them to be stronger and stronger and stronger until what? The baby pops out. It's some climactic event, okay, that you're going to. That would be positive feedback. When we see it here about temperature control is a classic negative feedback, keeping your temperature just right. You can go, if you're working out on a cold morning, you go for a run. At first you're what? Shivering, right? But then your body starts to make more energy and or use more of that energy and you're generating more heat and then you're starting to sweat. So you walk a little bit and then you might get cold. Okay, so you're trying to keep your temperature just right. That's a classic negative feedback. Contrary hormones, I already mentioned those, insulin and glucagon. Calcitonin and the parathyroid hormone are another classic contrary. Calcitonin, what does that do? Calcitone it down. Now, lowers blood calcium. Parathyroid gland raises blood calcium. Yeah. Okay, what happens when you secrete too much of something? What is it called? Hypersecretion. Too little is hyposecretion. Okay, hypersecretion. And I skipped over this. Positive feedback, baby. Okay, then the next thing we talked about, we have talked about so far, we have talked about comparing and contrasting the nervous system with the endocrine system. We have talked about the different ways that chemical messages are transmitted. We've talked about how they might help us to keep us at homeostasis, like negative feedback, or amp it up, like positive feedback. We have talked about when you secrete too much or too little, hyper versus hypo. We've talked about antagonistic hormones, all these things working to keep us in homeostasis. Now what I want to talk to you about are 2 different types of hormones. Okay? So you have protein hormones and you have steroid hormones. Now steroid hormones are underneath the umbrella of what? What's a steroid under? It's one of what is it? Lipids. Yeah, there's fats and steroids, right? Both of them are lipids. And you know your cell membrane is a phospholipid bilayer. So steroids have no problem crossing through a phospholipid bilayer. And their receptor is internal somewhere. Here we go. Lipid solubles going in. The receptor is inside, maybe in the cytoplasm, maybe even in the nucleus. That's where their receptor is. What they tend to impact, steroid hormones, they tend to impact protein synthesis. Some protein products. So they're going to impact your DNA and what proteins are generated. You don't have a lot of hormones that are steroid hormones, just the ones from your, what am I being now? Ovaries or testes, or from your adrenal cortex, the outer part of your adrenal gland, which if you remember, that's long-term stress, like stress over a semester. Adrenal medulla, the inside, is stress like right before a quiz. Okay, fight or flight. Those are your steroid hormones. Most of your hormones are protein hormones. They cannot cross the phospholipid bilayer because they are what? Large or charged. They cannot go across. So they stand at the door and what? Knock. And they trigger some secondary messenger. Something that's allowed to go in the cell or trigger some reaction within the cell in order to get its action, whatever that might be. So 2 different types. There's another picture in your book that looks like this, comparing and contrasting them. I encourage you to look at that. Here is a classic second messenger. Okay, So here's epinephrine, fight or flight. Another name for that is adrenaline. It binds to a receptor, which ultimately triggers cyclic AMP. Cyclic AMP is the second messenger inside the cell. Okay? A second messenger could be calcium. And that's in a signal transduction pathway where you have something receive, some action, and some product. Signal transduction. Something receives, some action, and a product. So, anyway, that's that one. Okay, let's do some more. And I'm going to pause you again just for a momento. All right, so welcome back. Let's check to see how you did. So peptide water-soluble hormones are received by a receptor located in the plasma membrane itself, not one inside the cytoplasm, right? Who does that? If you're a steroid hormone, you can go in and be received inside. Otherwise, you've got to stay outside. You don't get to come in. So if both B and C cannot be correct on that one. Number 2, steroid hormones bind to receptor inside the cell, and they do impact protein synthesis. Any questions or concerns on that one? Okay. So now the next thing, I have this little review game. If we have time, we will do it. Okay. Is basically knowing all your different glands and hormones. So let's start with the tricksy one. Okay. The hypothalamus pituitary gland. So let's just focus just on that. Okay. The hypothalamus is full-on nervous system. Pituitary is full-on endocrine system. The two are connected by a stalk. Okay. And there's 2 lobes to the pituitary gland. The posterior pituitary gland drop down, post-pit, drop down in the back, okay? Directly connected to the hypothalamus. And the hypothalamus has neurosecretory cells that stretch down from the hypothalamus all the way into the posterior pituitary. These neurosecretory cells secrete the 2 hormones that the post-pit even, releases. He doesn't even have to make it. He's like, okay, I take them, I hold them, you tell me when, and then he will release them. Okay? So his 2 hormones are oxytocin. We already know that one. Oxytocin, what does that happen? We'll do milk and baby. Out hormone, right? Baby comes out, give it some milk that comes out. Oxytocin. Okay? And then the second one is ADH, which did we learn that one? Antidiuretic hormone, right? So that's the one, so you retain water, okay, when you have ADH, because I don't want to die, so I'm going to keep the water and not pee it out, okay? The anterior pituitary is not directly connected because it grew up and out of the mouth and globbed on. So the neurosecretory cells from the hypothalamus only got as far as the stalk, okay, because it wasn't there when it was growing, just was still moving out of the mouth area. So the anterior pituitary, what happens is the hypothalamus sends releasing hormones to a capillary bed in the stalk, reforms like into a venule, goes back out to capillaries again at the anterior pituitary. This is one of the 3 places where you have double capillaries. Where were the other places? Stomach and intestines, right? Hepatoportal vein, which then goes to your liver to regulate blood sugar level. Thanks, baby.
Thank you.
And then the second place was where? Did I teach you that already? The kidney? Huh, that's why you don't know. Okay, so, sorry, like, I don't know, is that you knew, right? Of course you did, because we already learned it. Okay, that's coming up for you. Okay, so what happens with the double set of capillaries here is the hypothalamus secretes releasing hormones, and then the pituitary will secrete, triggered by those releasing hormones, stimulating hormones. So these are all stimulating hormones. TSH stimulates the thyroid gland, right? Okay, ACTH, it stands for adrenal corticotropic hormone. Adrenal cortex, what do you hear in that? Adrenal cortex, that's what it stimulates. Prolactin, I am all for milk. Prolactin, what does that do? What? Milk production, right? So you make the milk. If you want milk to come out, what's the hormone that makes milk come out? Got to have some milk in there, right? So prolactin makes the milk, stimulates that production of milk in the mammary glands. Oxytocin makes it come out. Okay? GH, growth hormone. What do you think that's going to do? Make you grow. Affects your muscles, affects your bones. FSH and LH are gonadotropic hormones. They affect your gonads. Your gonads are your ovaries and your testes. Yeah. FSH makes you make sperm. And in females, what do you think it makes you make? Eggs. That would be the counterpart. Good. All right. So we talked about when things can go bad. Central diabetes insipidus. You better insipidus some more water because you're losing some water there. Which one was in charge of water? ADH. So there's probably something with that secretion. You don't have enough of it. All right. We looked at some other problems like gigantism and dwarfism, right? Too much growth hormone, not enough. Those you didn't have to get tested on. Let's try these. And we're going to pause you again. You know it. And you won't even notice that you're paused. It'll happen in a nanosecond. It's like time has stopped. Okay. And welcome back. You didn't even know you were gone. Here we go. End. So oxytocin is released through positive feedback and causes uterine contractions. And then here, tall basketball players, giants and dwarfs are a result of too much or too little growth hormone. Which gland secretes it? Anterior pituitary. One of you said the adrenal cortex? No. There's 3. We don't need to go over those right now. And F, thyroid gland. No, what's the thyroid gland about? Your metabolism. Now, if your metabolism is really slow, you will not grow. Okay? But that's not going to make tall basketball players. Okay? What's I? Post-pit. No. What 2 hormones come out of the post-pit? Oxytocin and ADH. Okay? All right. Moving on. So then let's talk about, here you have your thyroid gland, and on it is your parathyroid glands. From your thyroid gland, you have 2 hormones. Thyroid hormone, all about your metabolism. Okay, your metabolism. And then calcitonin, we said calcitone it down now. Let's lower that blood calcium. And like, what you're going to do is you're going to store it in your bones. Calcitone it. Calcitone. I'm going to lower blood calcium. I got to put it somewhere. Think about it. I don't know if that helps you. Never mind. Parathyroid gland does the opposite. Raises blood calcium levels. Now, there is a connection between your hypothalamus, your pituitary, and your thyroid gland. So most simply, the thyroid gland, the hypothalamus is going to secrete thyroid releasing hormone, which will make the pituitary gland secrete thyroid stimulating hormone, which will make the thyroid gland secrete thyroid hormone. And as the thyroid hormone level elevates, it will go back here and shut those off. Okay? If it shuts those off, then over time, what's going to happen to the level of thyroid hormone? It's going to go down. And if it goes down, then it'll stop shutting those off so that they will be secreted all over again, so that you get more thyroid hormone. And when the thyroid hormone level gets there, it's just like your oven. Set the temperature at 375. It's going to heat up until it gets to 375. And that temperature is going to shut off the heating coils. If you open up the door to put in your plate of cookies, right, little heat's going to escape out. And so the temperature is going to drop. It's going to turn back on again. What kind of feedback is that? Negative, because you're keeping it just right. You're correcting it to the right temperature. Okay? This is a good connection because it connects the whole regulatory process and also shows how different glands interact. So your releasing hormone comes from the hypothalamus. Then that makes the pituitary gland secrete stimulating hormone. The stimulating hormone does stimulate the thyroid gland, so it releases thyroid hormone. And then as the thyroid hormone level increases, it exerts negative feedback on both the hypothalamus and on the pituitary gland. I can't hear my class. It's okay. Very kind, loving children, though. Okay, questions you want to ask me about that? Okay. All right. Whoops, goiter. Okay, now, why would you have goiter? See, you won't even be shocked when it happens in class for you. Okay? Goiter is a very large thyroid gland. Why is it so large? Because you're not making thyroid hormone. One of the things you need in order to make thyroid hormone is iodine. If you don't have enough iodine in your diet, you won't make enough thyroid hormone. So the hypothalamus is screaming at the pituitary, the pituitary is screaming at the thyroid gland. It's like, okay. And all of that screaming with thyroid stimulating hormone on the thyroid gland makes it get bigger and bigger and bigger. How do we solve the problem? Get what in our diet? Iodine. That's why we have iodized salt. Okay? So we never are short of iodine. All right. Graves' disease is too much thyroid hormone. There's some other ones in there too. And that's a hyperthyroidism. Okay. Adrenal cortex. The outside of it, long-term stress. Stress over the course of the year. Stress over your class. Stress over the course of a season. Right? The adrenal medulla is fight or flight. It's in the moment. It's, oh, I have this quiz. Oh, my mom is yelling at me. Oh, I just won the prize. Oh, I have to do a speech. That's fight or flight. Adrenal medulla, long-term sustained stress is adrenal cortex. Next, pancreas is both an exocrine gland and an endocrine gland. Exocrine gland related to digestion, endocrine gland related to the endocrine system. There are islets of Langerhans. You have alpha and beta cells in there. The beta cells secrete insulin. The alpha cells secrete glucagon. Between those two, the levels are just right. What kind of feedback is that? Negative. Almost every system in your body is about negative feedback. Only a few are about positive feedback. All right. We talked about diabetes. There's two types, type 1 and type 2. Type 1 is juvenile onset, and that would be because you had an autoimmune disease, and we learned about autoimmune diseases already that destroyed your islets of Langerhans. So you're unable to secrete insulin, specifically your beta cells. Type 2, generally speaking, you bring that on yourself because you put so much sugar in your body, sugar, okay, that it's like screaming all the time for insulin, and pretty soon it thinks that's the norm, having sugar levels that high. And so you end up, your cells are not receptive to insulin because insulin is always out there, that it starts to ignore it. It thinks that's the norm. It looks for change. So that's type 2. Be overweight, eat too much sugar, you too can have type 2 diabetes. Okay. Hey, guess what we're doing again? That's right. Time to say a little pause. You wrote testes? Let's see. That's awesome. Okay. Testosterone. Testosterone, muscles, strength, and then also some other things we don't think about. Maintains bone density, aids memory. Those are things sometimes we don't think about that are part of testosterone. I don't want you to take testosterone in excess. I don't want you to take it at all unless you have to, right? Because then it starts exerting negative feedback on your testes. Female estrogen and progesterone are the two classic ones. All of these are steroid hormones. All right. Thymus gland. Shrivelly as you get older, because the thymus gland, you already know, that's where what happens? T cells mature. T cells mature in the thymus gland. And the hormone is thymosin. Okay. And then the pineal gland. The pineal gland is known as the third eye. It detects how much light, and when the lights go down, then the melatonin goes up. And if you get bright light, then the melatonin's going to crash. So here you can see that, let's say here's a normal winter's night's sleep. You have this much melatonin. It goes up as you sleep. As you're getting towards wakefulness, it goes down. But a bright light can force it to crash early, and then you don't necessarily get the right kind of sleep that you need. In the summer, you have less. This is how animals know when to hibernate, when to reproduce, because of they can tell the seasons. I mean, I guess you could look outside and go, well, there's snow. Okay, but it affects their sex drive as well. Okay. And then I'll have you do that if you want to, but do the other hormones. On the other hormones, we call them other because they come from cells and tissues and not endocrine glands as part of the endocrine system, but they still communicate. One of those is leptin, and adipose tissue secretes it, and it says you are full. I always think leap up from the table. Don't keep sitting at the table. Leap away from the table because you are full. You will not secrete leptin if you eat so fast that you don't allow your body to have a sense of fullness, right? That's why you don't want to eat too fast. Growth hormone, You should not overtake growth hormone, okay, unless you're in need of it for some reason, because that can be bad. EPO, I don't think I'm testing you on that one, but it is secreted by your kidneys. Prostaglandins, usually these are showing pain. When you have prostaglandins, it's like a warning sign, hey, I've got a problem over here. And then pheromones, I already mentioned this one. Pheromones are between two different organisms, whereas hormones are between two different body parts. We know that tears can make you secrete less testosterone, boys, and that makes us actually happy because you shouldn't make us cry. But we also know that you are attracted to males that have different MHCs than you, which would increase your variability of your offspring, right, and what MHC receptors they have. All right, and some secretions like axillary secretions could be a type of pheromone. All right, very good. Wait, I think that's a game. Wait, do I want that? I don't want that. Is that the game? No, that's not a game. We are back. Okay, let's see how we did. Good job on number 1, goiterlicious. Okay. Oh dear. Hormones from all but which of the following glands could affect glucose levels in the thymus gland? Now, even if you didn't know about the other ones, you should have guessed thymus. Why should you have guessed thymus? What happens in the thymus? Maturation of T cells. Does that have anything to do with glucose? No. Pancreas, yeah, nobody picked the pancreas. Adrenal glands, yes, adrenal medulla, fight or flight, you're gonna need sugar, but really it's from the adrenal cortex. Pituitary, yes. Hypothalamus, yes. Even if you didn't know all the specificities of the hormones, you should have known that thymus definitely doesn't affect glucose levels. Number 3, 6 of you got this right. Oh, that's a hard one. I didn't have you memorize that one this year, so don't stress out about that one. It is a result of thyroid hormone. Okay. Number 4, name the hormone, or match the hormone to the gland. Oxytocin storage. It gets stored in the posterior pituitary. Okay, it's made by neurosecretory cells coming out of the hypothalamus, but it is stored in the posterior pituitary, and then it is triggered for release. Good. Growth hormone is anterior pituitary. 2 people picked post-pit. What are the only ones that come out of the post-pit? Oxytocin and ADH. Okay, number 6. Which gland secretes a hormone that stimulates the formation of milk in the mammary glands? That would be the anterior pituitary, and name that hormone. Prolactin. Good. Which gland secretes a hormone that stimulates the release of milk? What's the release of milk? What hormone is that? Oxytocin. Who stimulates it? Post-pit. Name the hormone epinephrine. That's adrenaline, and that comes from your adrenal medulla. What's another one that comes from your adrenal medulla? Norepinephrine. Anger. I'm angry at you. Peptide hormones are received by a receptor located in the plasma membrane. They stand at the door and knock. Whoa. And the chief difference between endocrine hormones and local hormones is the distance over which they act. Prostaglandins are local. They affect the local tissues, whereas the other one is over a distance. Okay, I don't know what there's 3 questions here. Do you want to answer them?
Sure.
Okay. All right. Okay, guys. Time for you to pause again. Okay, we quit a little early because they're typing ones and the bell's already rung, so let's just go over them. Ah, digestion and also regulates your blood sugar, pancreas, not thymus. Not thymus. Okay. Number 2, which gland helps regulate your metabolism? That would be the thyroid gland, not thymus. What's the thymus gland? T cells. What's the hormone? Thymosin. It's easy to remember. Thymus, thymosin. Like, sure it is. Oh. Pituitary gland is the master gland. Hypothalamus is nervous system. Okay, and if you want to, I have a little speed racer game. You can take turns being the race car, I guess. Where are you? Where are you, speed racer? And you know what? I hope you have a great evening, and I guess they can watch if you want. I need some volunteers to come up here. Yeah, volunteers. 4 racers, 4 people.
How does this work? Oh, wow.
Pick which thing you want to be. Come on up. Oh, sorry, I'm going to pause you for a minute. Listen, you should review. Don't forget your additional objectives. You're super smart. Make good choices. Have a piece of toast.